One.
Okay, this is part 5 of our formative review. Number 18 is where we're beginning. It's asking for the gram formula mass. The gram formula mass is equal to the molecular mass. So if you know how to read the periodic table, and I hope you do by now, we should be able to calculate that calcium in this particular molecule, calcium phosphate, is 3 times its molecular weight, 40.078. Phosphorus, there are 2 of those, 2 times its molecular weight, which is 30.974. There are 8 oxygens in this molecule, so 8 times oxygen's molecular weight. And when you add all of those together, you'll have your answer in grams per mole of calcium phosphate. Number 19. Number 19 is asking what the molecular formula of a compound that has a molar mass of 42 and an empirical formula of CH2. So what we're looking for is a 2-to-1 ratio in our answer. It looks like all of our answers, well, one of our answers can be eliminated right away. D is not a 2-to-1 ratio, C4H12. So let's look at A, CH2. The molecular mass of that one is going to be 12.011 plus our molecular mass of hydrogen times 2. That's our answer in grams per mole. Now let's look at B, C2H4. We have 2 carbons. We'll take 2 times the molecular mass of carbon plus 4 times the molecular mass of hydrogen. That's going to give us our molecular mass for C2H4. And now let's look at C. That's C3H6. We're going to take 3 times our molecular mass of carbon plus 6 times our molecular mass of hydrogen, and that's going to give us our molecular mass of C3H6. And you'll just need to see which one of those adds up to 42. Since that was our given molecular mass. Number 20. Number 20 is asking us about a compound with an empirical formula of CH2. We know an empirical formula is the simplest formula, and it has a molecular mass of 70. So we look at all of our answers. All of our answers this time include that 2-to-1 ratio that we're looking for. So we're trying to find the one with the largest mass, probably. Since it's a molecular mass of 70, If we look at choice A, CH2, that's just 12 plus hydrogen, which is 2. We're not going to choose that one, it's too small. When we look at choice B, that's C2H4. That's also going to be much smaller than 70. So we can ignore that one too. When we look at choice C, we're getting closer here with C4H8. That's going to give us 4 times the molecular mass of carbon, which is 12.011, plus 8 times the molecular mass of hydrogen, which is 1.008. That's probably going to get us closer to our answer. But let's look at D, which is C5H10. We need 5 times our molecular weight of carbon plus 10 times our molecular weight of hydrogen. That's going to get us a pretty large molecular mass. So you'll need to choose between these two, which one equals 70. Since that was our target molecular weight. Number 21. We are asked to find the gram molecular mass of the compound with the formula CH3COOH. Okay, so now we count atoms. We have 2 carbons, so we take 2 times the molecular weight of carbon, and we get that answer. And then we take our hydrogens, and we take 4 times the molecular weight of hydrogen, because we have 4 hydrogens in our compound. Then we look at oxygens, and we count 1, 2 of those. So we take 2 times the molecular weight of oxygen, calculate that. Our C plus our H plus our O is going to give us our total grams per mole.